particular lines that you could be looking at. So, you should be identifying its slope. You should be, for parallel, using the same slope. You should be using point slope form. Y minus y1 equals n times x minus x1. You should be thinking about, okay, is this really how people do this? Is this really how people plan paths and parks? A park and recreation department wants a bike path that is parallel to the railroad tracks. Here's the railroad tracks. The path is supposed to be parallel to this. However, Romani, what does it say is a condition about the bike path? Yeah, it has to be parallel to the train track. What else has to be true about it? Have you read it? Take a minute. Take a minute. Read it. Oh, it has to go through the parking area. So the bike path has to go through the parking lot and be parallel to the train tracks. There's one more condition. And they don't want to take any trees out. That's a rule for the Parks and Recreation Department. So they want a parallel line going through the parking lot that won't run into trees. Is it possible?
I mean, maybe if it's really skinny.
Yeah. Well, look at this. Look at the width of the train track. The train track fits right in between some trees here.
Yeah, and if you make the bike path like really small on the side of it, maybe.
But the parking area is all the way over there.
Oh, I didn't think about that. 92, it has a one.
I don't know. I'm gonna have to write a line, graph a line, do the whole thing. Alright, it specifically says it has to go through 4,5. So right here, this corner is where the bike path they wanted to hit. So that's going to be x1 and y1. Parallel. So what should be the slope of our line, our bike path line? Maybe. Let's look. It sounds like a really good guess. I know it's much harder for you guys when I projected it here. So let's see, what is the slope of this train track? 1, 2, 3, 4. Up 4. 1, 2, 3. Good job. The slope is up 4 over 3. So I guess I could just write on the screen and we could figure this out. 1, 2, 3, 4. 1, 2, 3. Okay, that's a bike path there. Can it continue through the park this way? Sure does hit this tree right here. No, I think the answer is no. They can't do it now. There's a condition. If they just start the bike path here, then they're good. But if they want to start down here at this corner, they're gonna have to take out this tree here. Yeah, part of the trees. It says you cannot intersect trees shown. So the answer is no, they can't. Nope. I put a condition here. I put unless it just starts at 4 or 5. If their bike path, if they want to just start it here and then go that way, it's fine. But if they want to go this way, no. Cool. I didn't even use the formula. I just wrote on the thing. I'm going to do the formula really quick. Because based on mine, 1, 2, 1, 2, 3. Based on the y-intercept is a fraction. Did anybody do point slope form and find the y-intercept? I think it's going to be like negative 1/3 or something. I don't know. I'm going to try it. Oh, I was right. You don't have to. This is for those students in here that are really in this.
That's a lot of work.
Okay, if I wrote the equation for that parallel bike path, this is what it would be. I just put in the 0.45. I put in the slope. I distributed slope and got a fraction. And then I added 5 to both sides. How did I go from 5/1 to 15/3? And why would I do that? Anybody in it? Anybody in it? Yeah, I did a common denominator. Nice job, you guys. Very good. So I went ahead and, because I had to add the 5/, negative 16 plus 15 is negative 1. And that lines up with my drawing. Here's 0 and here's negative 1. So the equation for this starts at negative 1/3 and goes up 4/3. All right, guys. So your assignment Thursday was online. Hope you got that done. You're scheduled to have a quiz on Thursday this week, and this parallel perpendicular bit was the last thing to cover. So I have a handout for you. I feel like I can't give this to you until I make you write something down. It's 3 sections. I'm going to give you a few notes to write next to each section so that you're successful getting some work done. You may write and keep, you can write on this and keep it. Yes. And I think, if I give an open note option on the quiz Thursday, so you can use this on the quiz Thursday if you want. But if you choose to do open note, you can't get higher than 80. Okay? These quizzes have proven to be really difficult.
Exactly. She's gonna give us no favor. He needs one back there.
Okay, I think I give him enough. Everybody have a handout now? Alright, guys, go ahead and label this so that you know where to look for examples. Your first one, so notice it says little mini assessment on here. I pulled these from your book. The first one is chapter 4.1, and then this one is chapter 4.2, and then down here is chapter 4.3. All right, in 4.1, we focus primarily on slope-intercept form as well as slope formula. So I want you to consider both of those. And it was chapter 4.2 where we started doing y minus y1 equals m times x minus x1. And then come 4.3 is the parallel and perpendicular concept. So remember, parallel is same slope, while perpendicular is opposite reciprocal. I feel like I haven't done enough perpendicular examples with you, so there's one problem down there with perpendicular. All right, so you're gonna start 1 and 2 right now on 4.1. Sorry, and then perpendicular isn't told, right? I don't think. Let's just fix that. Perpendicular. So go ahead and let's see. I think you have all the skills to do 1 and 2. So try number 1 and number 2. Me? No, I want you to just try it yourself. Read it. Read the question. Read the question. Okay, cool. And so you wrote the green bit, right? Did you read number 1? Did you do number 1? All right. Do you know in the green bit which is where to put slope? The y, the m, the x, or the b? Yep. And do you know where to put the y-intercept? The y, the m, the x, or the b? The b. So go ahead, put it in, and that's the answer. So you bring up a really good point. Do you know why, if this is y-intercept, how come they didn't just call it y? Why would they call it a z? There's already a y. This is every point on the line. X and y is every point on the line. This y-intercept is the most special y value. So they had to call it something besides y. They called it z. The most special y value. Sure is.
Yeah, start to tally.
You write this.
There it is. Did anybody get that before me? Yeah. Very good. Now try the second one. Find the slope. Find the intercept. You can do it. Second one, you can do it. All right, number 2. You need to count slope. Count slope on number 2. Count rise over run. Identify B. B always has a 0 in the X. Who's on number 2? You can just, since they give you a picture, you can just count rise over run. All right, I'm gonna put the answer for 2 in a minute. If you're ready for 3, find your slope. Identify B. Same concept.
Be nice, give him that.
This is your. Not B. Okay, let's go. Did you do 2 yet? You're writing a whole equation. Listen. Number 2, you have to write a whole equation. Oh, I wrote slope formula there for you, but I just put it there so you know that might be useful. It's useful later on. Just, I guess that was misleading. Every time it says write an equation, they're looking for y equals mx plus b. So you got to find the slope and the b value. You want me to do that? Keep going. Keep going. I got for number 2, up 4, right 5. It's going uphill. I got up 4, right 5. For the b value, negative 1. The negative is hard to see. So the equation for number 2 is 4/5 x minus 1. Anybody get it right? Okay. 5-2.
Oh, yeah.
You did too? Alright, now you're supposed to be able to write that function notation as an x and y ordered pair. Did you write them as points? Try to write it as a point. Now you do have a bell work where we did that, if you can go back and look. Before I just tell you. Alright, number 3. What do you think the slope is of that table? Remember? Slope is change in y over change in x. How are the y's changing and how are the x's changing? It's going, the x's are changing, I say, up to. The y's are going
Down.
up 2. That is kind of hard to see. If you guys don't like to look at how it's changing, you can just do slope formula. Let me write the 2 points then. If I wanted to do slope formula, I would do -2, -13, that's x1, y1, and 0, -7, that's x2, y2. So you could just pick the first 2 points. x1, y1, x2, y2, and do the slope formula, if you prefer. Now for me, since I was able to see that it was up 6, I got the slope is 3, but I can see that would be challenging. The change in y is going up 6. The change in x is going up 2. Your slope is 3. -7 minus a -13, that's tough. 0 minus -2. Get your calculators out. What would you do if that was a quiz question? Would you be getting it right? You tried in that calculator.
You could say it. Probably damn near everyone in this room. Not that, but I mean, if she gave us this as a test, this was testing. My ass was grass. Which one? Oh, all right, I got too much energy.
So that's -7 plus 13 over 0 plus 2. That's 6 over 2, which is 3. So the table is showing a slope of 3. So now I'm at y equals 3x. But what's the b value? Colton, what's the b value? Number 3. Daisy, what's the B value? What? Oh, dang. Why would it be negative? Where's he getting that from? It's got to be in this table somewhere, don't you think? For him to just say that? Do you see a negative 7 in the table? Why is that number special from all the rest? Alright, the intercept, the B value, is negative 7. Colin, out of all the numbers in this table, why did you pick negative 7? Yeah, why? Dang, you were just guessing? You don't really know? It has nothing to do with it being first, second, third, or fourth. Because it's with a 0, y'all. Intercepts have zeros. Zeros make it special. Zeros are special. Pay attention. When you see a 0 on the table, you see an intercept. Alright. Are you all ready for number 4? Alright, I'm remembering that.
Sorry. I'm just mad right now.
Winter, did you figure number 4 out? No? What? You guys, can anybody find, and I give you an extra credit, if you can find anything in your notebook that explains how to do number 4. I'll take a page number in your textbook or a date in your notebook that explains how to do number 4. Here. Write the function name. Daisy, what day is that? That is November 6th. November 6th. Number 4. November 6th. Have you read it? Yeah, you do.
Can I have this?
I covered it twice. I covered this twice. So November 6th or November 3rd. Now, I'm curious because not everybody learns well from notes. So I'm going to wait a minute and just see how many of you can actually read what you wrote and apply it to this question. So can you look at, I think it's November 3rd or November 6th, and figure anything in this question out?
How do I have the one right after the one I need? Why are you looking like that? No.
I'm glad you just see the ghost.
Looking like the one with the switch.
Look at how you look when your mom comes through the front door. So you know it's not so good reason. You know you done got in trouble. I wish it. November 6th, November 3rd.
You drinking air? You got asthma or something.
That boy taking the lightest sips of water ever. That's why you in your situation right now. You clean your head with air. You won't get no knowledge. You just inflict air. Brain is air. Like that bitch is an inhaler, and that's not. Also, piss me off. Yeah. Take a drink and take a drink, but then there's nothing there.
All right, JR, what did you get? What's your slope? I can never remember. Could you find anything you don't have on this date?
I did, but it's just the work.
I literally have the date after the date that I need.
All right. So this is called function notation, and you need to write it as an ordered pair. This is the x value. This is the y value. So this is a point 0, -6. And this is another point 4, -6. So when you see function notation, your brain has to think of ordered pairs, x and y. The number in the parentheses is x, and the result is y. So go ahead, if you have to write an equation, you need slope. Find the slope between those 2 points. Oh, thank you. This is a positive. Thank you so much, Allison. How do you know? Because there's not a space. Yeah. Thanks. Find your slope. Find your slope. It's not 6. We'll call this x1, y1, x2, y2. It's going to be -6. Oh, you are right. I thought that was a -6. Over 4 minus 0. That's -12 over 4. -3. I got a -3 here. This is supposed to be positive. I saw it negative twice. I'm sorry, I'm messing it up. Well, no, the formula has a minus sign in it. All right, what's the Colin? What's the equation in number 4? Did you do slope formula? Maybe try it. Okay, well, you know it's y2 minus y1. I've seen you do slope formula so many. You know how to do it. Y2 minus y1 over x2 minus x1. And you plug in from these ordered pairs. Yes. Yep.
I hear someone crying.
How's it going? Are you guys ready for number 5? Now listen. Negative 6 minus 6. Go ahead and subtract it. What's 4 minus 0? Yeah. What's negative 12 over 4? Negative 3. Yeah. So your slope is negative 3. Now, Sarah, I heard you say this. You said, is the answer, actually, what did you say? You said y equals, or did you say f of x equals? Yeah, so I would write y equals negative 3x plus 6. That's an equation. Now, since these directions say to write a linear function, and the ordered pairs weren't given to us real straightforward, they use the f of x format. Really, we should make this like kind of more advanced, and instead of y, write f of x. So everybody, even if you worked ahead, you got it right. Change your y into f of x.